Which of the following functions is not quadratic? So in order to answer a question like this, we want to remember just the standard form of a quadratic function. Recall that the standard form of a quadratic function is going to look like this. It has some leading coefficient of a multiplied then by our variable, in this case it's x squared, plus then some coefficient of b multiplied by x just raised to the first power, plus some coefficient c. Now, the most important term, remember, is the x squared term. In order for a function to be quadratic, it has to have, algebraically, it has to have at least an x squared term in it, or a variable squared. Okay, and it cannot be a negative. There should be no negative terms here. All right, you must have the x squared, and you might have then x to the first power, and that's okay as well. But remember, the most important term is the x squared. Now, when we look at our choices here, we have to make sure that before we come to a conclusion, we have to make sure that we have simplified our functions as much as possible. So for example, in terms of number 1, if we did a quick analysis and we said, okay, is this a quadratic function? We might look and say, uh-oh, we have x to the 4th power. Nope, can't be quadratic. And that would be then our answer based upon that rationale. However, that would be incorrect. The reason for that is because we can simplify this. We can simplify this. So how would we do that? Well, over here, we would have, I'm going to write it down, x to the 4th plus x squared, all divided then by x squared. Now, one of the rules of algebra is that if I have multiple terms in the numerator over a single denominator, I can basically break this fraction up into two smaller fractions. So I can write x to the 4th over x squared plus x squared over x squared. In other words, I can basically take this denominator and kind of distribute it over under each of the numerators. All right. Now, when I look at it in this way, I realize that I can now start to simplify these terms individually, right? So if I were to look at this term and simplify it, x to the 4th divided by x squared is just going to be x squared. Remember, when you divide common bases, you're going to subtract the exponents. Okay? Same thing over here now. We're going to take x squared divided by x squared, and we realize that that just works out to be 1. Right? Whenever you divide something by itself, it cancels it out. Don't make it a 0, though, right? Careful with that. It's not 0. It's equal to 1. All right? And if we thought about that by using the same logic we did before, if you did 2 minus 2, that would be 0, x to the 0, but any variable raised or any number raised to the 0 power is just equal to 1. All right, so that's another way to kind of look at it. So this would actually be the simplified function. Now, is that a quadratic? Well, indeed it is. So we got to be careful, okay? So this, upon first glance, does not look quadratic because we have that x to the 4th, but upon simplification, we do see it actually is quadratic. So if you can simplify it and you find your quadratic, meaning that you have that x squared term somewhere in the numerator, better not be in the denominator, then it is indeed a quadratic. Taking a look at our next choice here, 9 minus x squared, this is totally fine, right? This is definitely a quadratic function. We have an x squared term here. Don't worry, we don't need an x term at all. As long as we have at least an x squared term in there, and no more than x squared, it can't be x cubed now, that would be a cubic, that indeed is a quadratic function. So we can move on to the next answer choice. So here we're going to take a look at this. Now this actually is right now in standard form, and this is a perfect example here of this standard form function. Now notice how I have x squared. Now remember, there is a coefficient here. It is a value of 1. Okay, there is a value of 1 there. So this is ax squared plus bx plus, now that's c. It's just a number. It's a fraction, right? It looks a little scary, but it's just a number. Okay, it's just a value. So that indeed is a quadratic. Now basically, by process of elimination, we would come to the conclusion that this is indeed our answer. Why is that the answer though? Well, for the following reason. Even though when you first look at this, it looks like we have x squared. We have an x squared here and an x squared there, so that might be okay. However, you can rearrange this. X squared, you should not have a variable squared in the denominator. Okay? Now recall that in our first example, I did have x squared in the denominator, but I was able to do some simplification to basically cancel that, okay? In this example, I can't do any simplification here. It's just living in that denominator, and I can't really bring it out of the denominator, but if I did, well, I guess I could then, right? I can bring it out of the denominator, but if I do bring it out of that denominator, the sign of the exponent becomes negative. So for example, if you take 1 divided by x squared, and you flip the fraction, you do x squared over 1, you flip the fraction, you got to make sure you flip the sign there. That becomes a -2, and that's a problem. All right, so instead of writing this, we could have written x to the -2 in its place, and that's just not a quadratic. Nowhere here is there a negative exponent. All right, so what that basically means now is that this is indeed our answer. That is not the quadratic. If you like this practice example, check out our website, glazersguide.com. We got thousands of practice problems on there just for you, and we'd love to help you every step of the way. We'll see you there.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.